Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 127, word ladder. A transformation sequence from word begin words to word end words using a dictionary. Word list is the sequence of words begin words to S1, S2, all the way up to SK, such that every adjacent pair of words differs only by a single letter. Every SI for I between 1 and K is in the word list. Note that begin words are not need to be in the word list. And then this SK equals to the end word. So the end word has to be in the word list. Given two words, begin words and end words, and the dictionary word list return the number of words in the shortest transformation sequence from begin words to end word, or 0 if no such sequence exists. In the example 1, the begin word is hit. The begin word is not in this word list. And then the end word is COG. The end word has to be in this word list. And then the number of transformation. One of the possible shortest transformation sequence is from hit to hot. Hot in this word list. From hot to dot. So it differs every time. It only differs by one character. So hot to dot differed only by the beginning character, and from dot to dog, and from dog to COG, which is 5 words long. So 1, 2, 3, 4. That's 4 words, and then with the begin words, so that's in total is 5 words. So this 5 words includes the begin words and then the end words. So in this case, begin word is hit, end words is cog. In this case, the word list is a little bit different than the word list in the example 1. There is no COG, so the end word is not in this word list. So therefore, there is no valid transformation sequence. So how to solve this one? So basically, the idea for solving this one is, let's say we start with the begin words, and then we are trying to find the possible transformation. So from the begin words, we can see, okay, what if I change the first character? Let's change this H to some other character. Does my word list contain something like star IT? And then another option is to change the middle letter I to something. So in that case, the word list has to contain something like H star T. Star means any character. So the word list contains HOT. So we can replace that I with O. Or from here, from the hit HIT, we can also consider transform the last letter T, so it becomes HI star. Star means any characters. So can we find anything match HIT in this word list? No, we cannot find it. So in that case, by considering all the 3 possible options, the possible option is to transform this HIT into HOT. So that's kind of how we find the next steps. So basically, given the current word, how we find the next word. And then so that's kind of the method for solving it. Basically, given the current word, we are trying to identify what is the next word. If the current word is already, let's say, equal to the end word, in that case, we know that we have already find one possible transformation sequence. We can just end there and return the number of number of words. So this is essentially very similar to the shortest path problem. So for shortest path problem, we solve it using BFS. So here, let's let's take a look at example 1. When you are given a word list, HOT, DOT, DOG, LOT, LOG, COG. So from there, we construct a mapping dictionary to help us in determining the next words given the current word. So how we construct this mapping dictionary? Basically, we examine every word in this word list. And then the first word in this word list is HOT. So we are trying to replace it by identity. So in this mapping dictionary, the key is possible patterns. Let's say start OT, which means okay, any letter start with any letter, and then the following letters in this word are OT. So how many of words having this pattern in the word list. There are 3 words, HOT, DOT, lot, and then LOT. These 3 words has the pattern of star OT. Star means it can be any characters, and OT means the character O and character T following the stars. Similarly, what is the how many words match the pattern H star T? One word HOT. How many match the pattern HO star HOT? So in this way, we are constructing a mapping dictionary. The key of the dictionary is the pattern, the word pattern. And then the value of the dictionary is a list of all the words that matches this pattern in the word list. So this will help us in determining what is the next words, or what is the next step given the current words. Other than that, it should be a pretty standard BFS implementation. So let's try to code this up. First, construct mapping dictionary. For word in word list, for C in word, and then let's have a dictionary. Mapping dictionary equals this one. The key is for I in last word. So basically, we check every word in this word list, and then for each word, we check every position, every character in this word. So key equals word I plus the star plus word I plus 1. So the idea is, okay, for each position in this word, we're trying to replace that with the star. So for example, for HOT, we were trying to replace the first character with star. We try to replace the second character with star, and then third character with star. In that case, we create the pattern star OT, H star T, and HO star. So basically, this is the process of constructing those the patterns. And then if key not in, if key in mapping dictionary, in that case, we just mapping dictionary key dot append this word. Else, if key not in the mapping dictionary, so mapping dictionary key equals word. Okay, so in this way, we construct our mapping dictionary. So we need to use this mapping dictionary to help us determine the next word given the current words. So after that, let's do our BFS. So we need to use Q. So from collections import Q. Q equals the Q. At the very beginning, we have the begin word. And then while Q, we pop the word equals Q dot pop left So we pop a word from the queue. Okay. So in this queue, let's also track the steps. So steps. So in this case, word steps equals queue.popLeft. At the beginning, the steps should be 1. So because we need to return the number of words, so we count the begin word as well. So at the very beginning, it should be 1. And then we pop it, and then we need to determine the next word given the current word. So in that case, and then we also need to keep track of if we have visited the word before. We do not want to repeatedly visit the same word. Let's say if we have already reached some word in the previous steps, in the later steps we do not want to go back to the same word again. So that's why we use a set to track of the word that we have already visited before. So, and then we need to determine the next word. So basically for I in range length of word here, key equals, basically we can copy paste the previous one. So basically we are trying to construct the pattern given the current word, and then so that we can determine the next word. So basically for I in this array position in this word, we are trying to replace that character, the character at that position with a star, so that we can do the transformation but only change one character in this word. And then for next word in mapping dictionary key, if next word not in visited, if the next word has not been visited before, we append the next word, and then also steps +1. So before that, so we need to check. So check if we visited. So we need to add this word to the visited. So visited dot add word. So if this word equals the end word, we just return the steps. So that's our stopping condition. Otherwise, start visit this word and then we determine the next word. And then if we tried all the possible operation, tried all the possible options, and we still cannot reach the end word, we just return 0. So let's try run the code. But before that, first I try to check our BFS implementation. We have a queue, and we put the begin word in the queue. We have a set visited to keep track of the word we have already checked before. And then while this queue, we just pop this word and the steps from the queue. And then if this word equals to our end word, we just return its steps. Otherwise, we add that to visited and then start visit this word and determine the next word. For I in range length of word, we're trying to construct the pattern by replacing or change one character. And then for all the next words, if this next word is not visited before, we just append that to the queue. Okay, so the index not exist arrow. So that's why I need to use get. Map dictionary, try to get this key. If key does not exist, return the empty list. Okay, so this is my solution for solving this problem. So the idea is using BFS. The reason why it's using BFS is, okay, return the number of words in the shortest transformation sequence. And if you look at this problem, it's more like it's very similar to a shortest path problem. Basically, given the current word, you need to determine the next word, and then there's several possible candidates for the next word by just change one of the characters, and then you need to return the shortest transformation sequence. So in that case, it's the shortest path problem. That's why we use breadth first search to solve it. And then the key for solving this problem is trying to construct a mapping dictionary in order to determine what's the next step given current word. So given the current word, what could be the next word? So in that case, the key idea for solving this is using a mapping dictionary with key is the possible patterns, and then the corresponding value is a list of the words in the word list that match this pattern. How do we determine those patterns? So those patterns are determined from this word list. So by working backwards, we check every word in this word list and then to see, okay, what kind of pattern can we get after just by masking or changing one character in this word. For example, given the HOT in this word list, so one way to change it is to replace the first character H with some other characters, and then we represent it using a star, which means any other character, any characters. And then star OT, it corresponds to HOT, DOT, and LOT in this word list. That's kind of how it facilitates us to determine the next word given the current word. So that's kind of how we construct the mapping dictionary. So this block of code is how we construct that. And then we implement the standard BFS. We use a queue, and then here we use the Python DQ. It's double-ended queue implementation in Python. At the very beginning, it has the begin words, and then the steps is 1. So because it returns the number of words, including the begin words and the end words, and then we use a set of visited to track the word we have already visited before. So the reason why is, let's say if we previously reached the word DOT, and then now we are considering, okay, shall we go to the DOT again? No, we should not go to that the same word again, because that would be a longer sequence compared to the DOT we encountered before. Why? Because in BFS, so every time, every step, you are traveling the same speed. That's why the BFS is used to solve the shortest path problem. So every move or every step, you are traveling in the same speed. That's why the first one to reach the end point is actually the shortest path. It's one of the shortest paths. So if you later encounter the same word again, that path is definitely longer than the shortest path. So that's kind of a user visited set. So while this queue is not empty, we just pop the word and corresponding steps from the queue. And then we first check if this word is the end word. If it is the end word, then we can just return the steps because we have already reached our end word and we got the shortest path. If not, we add that to the visited and then determine the next word. Basically, how we determine the next word, similar to how we construct this mapping dictionary, we just try to replace every character in this current word with a star to construct our pattern. It's also the key for the mapping dictionary. And then we check the value for every value. That's kind of all the possible next words to transform into. So that's kind of what these two lines of code does. And then we check if this next word hasn't been visited before. Only in that case, we add that to the visited and we append that to the queue. In the end, if we check all the possible words, but we still cannot reach the end word, that's when we return 0. So this is the solution for the problem word letter. It's solved using breadth first search.